Alrighty, great. Thanks for the nice, peaceful fire drill. Now we kind of got to get rolling and make sure we get through our notes. This first page of notes is just kind of a lot of information. And so I don't even know if there's anything you guys really need to, there's nothing you guys need to write down on this page. Just make sure you're being attentive. It'll make the next couple pages a lot easier. So the first things first, we're going to kind of talk about the different words that we associate with circles. So the first thing we're going to do is a circle. We all know what a circle is. I feel confident about that. The next thing we're going to talk about is the center. The center of a circle, that's pretty easy. It's just the point that's right in the middle of the circle. The way we kind of think about the center of the circle is the center is going to be the same distance from any point on the edge of the circle. So that's kind of how we think about it in math terms. The center of a circle is just going to be the exact same distance away from any point on the edge of the circle. From there, the next vocab term that we're looking at is radius. It's right there on the board. It's that R word. So radius, plural radii, don't even really know that. But a radius is a line segment. Remember, a line segment is just a straight line that connects 2 points. So a radius is going to be a special line segment for us because it's going to connect the edge to the center. So as we can see, CD, line segment CD, that's point C, that's point D. Point C is on the center and point D is on the edge of the circle. Therefore, line segment CD is a radius for us. So that right there, that line segment, we would call a radius. Radius, there we go. The next thing we're going to talk about is a chord. A chord might be new to you guys. And a chord is just going to be a line segment where both endpoints are going to be on the edge of the circle. So do we think a radius is a chord? Any ideas? Do we think a radius, so do we think CD is a chord? No. So that's going to be a really important distinction. So to be a chord, both endpoints need to be on the edge of the circle. So like AB is a chord. CD isn't a chord because C isn't on the edge of the circle. So a radius is not a chord. A special type of chord is something that we call the diameter. The diameter is going to be a chord. So remember, a chord, both endpoints are on the edge of the circle. The diameter is special because it runs through the center of the circle. So the diameter is just a special chord that runs through the center of the circle. So for us, a diameter could be line segment DE because it's a chord. Both endpoints are on the edge of the circle, but it also runs through the center of the circle. So DE would be a diameter. So make sure we're labeling our circles. At least label that CD as a radius and DE as a diameter. If I said the length of DC or CD, however you want to think about it, that radius was 1 foot, what do we think the length of line segment DE or the diameter would be? Any ideas? If the radius was 1 foot? 2 feet, yep, exactly. So that's going to be a really important fact, and I think we're going to see that later. But the diameter is always double the radius. So the length of the chord that runs through the middle is going to be double of the length of the line segment that runs from the edge to just the middle. And it kind of makes sense, right? But the diameter is always going to be twice the distance of the radius. There's Miss Bryant. So moving on, what this says right here is that the radii, or all the different radiuses of a circle, are congruent. So that means no matter where you draw that radius, it's going to be the same length. As long as it's a straight line from the edge of your circle to the center of your circle, it's going to have the same length no matter where you draw it. The same is going to be true for diameters. All diameters of a circle are going to be congruent. They're all going to be the same length. So if we ever say two different line segments are both diameters, and we give you the length of one, that means we have the length for both of them. Moving on, looking at it here, this diameter formula says D, or diameter, equals 2R. So that right there is just telling us what we were already talking about. If we multiply the radius by 2, we're going to get the length of the diameter of a circle. In the same kind of thought process, our formula for R is going to be the diameter divided by 2. And that's the formula here that looks like a fraction, with D in the numerator and 2 in the denominator. So it's going to be really, really nice with circles, because anytime we have the radius or the diameter, we really have both. Because no matter what, the radius times 2 is going to give us the diameter, and the diameter divided by 2 is going to give us the radius, the length. So the next thing we're going to talk about is the circumference of a circle. Does anyone have any idea what the circumference is of a circle? What? Yep, so the way we think about it is the distance of like the perimeter. So we know the perimeter of like a square, we add up all the edges. Well, a circle is difficult, right? Because there's no straight edges. So how can we add it up? So the way we kind of find this perimeter of a circle, what we call the circumference, is going to be a special formula. And that formula is going to be, let's see where it is. Here, it's down here at the bottom. Our circumference is going to be pi times the diameter. So make sure you underline these two formulas right here. It's going to be super, super important. Maybe even draw a little star by them. In order to get the circumference, we just multiplied pi by the diameter. Raise your hand if you've heard of pi before. And yeah, right. So pi, it's a very special number to us. And the reason it is a special number is because of that fact. But it's also just a number. It's a number somewhere between 3.1 and 3.2. On our calculators, we have a special key that whenever we're finding the circumference, we'll just press the pi key and it'll give us that special number, that pi number. And all we need to know is that special number, pi, multiplied by our diameter, is always going to give us our circumference. Another way to think of it is our circumference is always going to be pi times 2 times the radius, or 2 pi r. And that makes sense because we know our diameter is equal to 2r, or 2 times the radius. So we can also get our circumference using that equation and just multiplying 2 times pi times r. And remember, that circumference, the way that we can think about it is it's just kind of the perimeter of our circle. It's the distance it takes to go around our circle, right on the edge. So now for example 1, we need to name the circle and identify a radius, a chord, and a diameter of the circle. So it doesn't have it written down anywhere in example 1, but one thing I would say is we could call this circle X. Oh yeah, it just doesn't have it right down. And the way we would do that is just circle X, or the center at X. And the reason we call this circle X is because our center point is point X. So that's going to be really important when we might give you like multiple circles on a question or something like that. Just remember, the way we identify a specific circle is by its center point. So underline that. From there, this circle, circle X, there's actually 4 different line segments that are radiuses. The first radius we have is line segment XV. So remember, that's going to be the line segment that runs between point X and point V. So that right there, what I just highlighted in red, is going to be a radius. Another radius that we're given is line segment XT. XT is just going to be that line segment right there between point X and point T. So like I said, there's 4 radii shown on this circle. And we've highlighted 2 of them. Does anyone see another line segment that would be a radii or a radius of circle X? Yep. XU? Yep, exactly. So the way we would write that is we would write X, we would write U, and then we would kind of just give it an overline. That right there is how we draw or write out line segment XU. And that is talking about that radius right there. Remember, the radius is a line segment that connects the middle of the circle to the edge. What's the only other radius that's on our circle that we haven't drawn yet? Any ideas? XZ, yep, exactly. XZ. We would write that, we would just write X and Z, the 2 points that are being connected, and then we say it's a line segment just by writing that overline over those 2 letters, over the 2 endpoints. The next thing we're asked to do is look at the chords. So while a radius is a line segment that connects the center of our circle to the edge, remember a chord is a line segment that connects 2 different points on the edge of our circle. So the first chord that we have is RS. And that's the line segment I'm highlighting in green. Just a line segment between point R and point S. Can anyone tell me another chord on our circle? The only other chord that we have? ZT, exactly. Point Z is on the edge of our circle. Point T is on the edge of our circle. So that line is going to be a chord. Right there. The way we would write that, the 2 points that get connected, Z and T. And then an overline, which tells us that that's a line segment. Line segment ZT. One thing that's super important to remember about line segments is that if we switch the order of the letters, we're still talking about the same line segment. So you guys said that ZT is a chord. Down there on that 3rd line, when we're talking about line segment TZ, well, we're talking about the same exact line segment. So please make sure you write that in your notes packet. TZ and ZT, ZT, and TZ are the same line segment. It doesn't matter which point you write first. So here, we see that TZ or the chord ZT, whichever one you want to think of it as, contains the center. So if a chord contains the center, does anyone remember what we call it? Diameter, yep. A chord is a line segment that connects 2 points on the edge of a circle. If it contains the center, then we think of it as a diameter. So maybe you guys can fit it. I'm going to write it off to the side. That's going to be the diameter. the diameter of circle X. Any questions on example 1? Awesome. So now we're moving on to example 2. So the first piece of information we get in on example 2 is that TU, or the line segment TU, this is just another way to write line segment. It just doesn't have the overline. But TU is 14 feet. What kind of line is TU? Is it a radius? Is it a chord? Or is it diameter? It's a diameter. How do you know it's a diameter? Exactly. We know a diameter is a line segment that goes from edge to edge and it contains the center. TU, T is on the edge, U is on the edge, and it goes through point Q, or the center point. Because we know the diameter is 14 feet, we just said TU is 14 feet, and it's a diameter, we could figure out the radius by going 14 divided by 2. You can make it like a fraction. You can type it in your calculator, just going 14 divided by 2, whatever you have to do. 14 divided by 2 gives us 7. So if our diameter is 14 feet, what's that 7 feet represent? Radius. Yes, exactly. Remember, if we divide our diameter by 2, that gives us the length of our radius. Here, our diameter was 14 feet. We divided by 2, and that gave us the radius of circle Q, which was 7 feet. Now let's look at this check. This check problem says that line segment LM is 11 inches. What kind of line segment is LM? Radius. It's a radius because M is on the edge and L is on the center. And we know that distance right there is 11 inches. I'm going to write it in. So we are given that our radius, or our R, is 11 inches. We are asked to find the diameter. What do we have to multiply by the radius to get the diameter? 2. 2 radiuses equals 1 diameter. 2 distances between edge and center added together are going to give us the distance from edge to edge, which runs through the center. What's a line segment on circle L that is a diameter? Yep, JK. JK is an example of a diameter on circle L. So like we said, 2R equals D. That's the formula. Well, our R is 11, so 2 times 11 is going to be 22. So the diameter of circle L is going to be 22 inches. Give me a thumbs up if it makes sense how to go from radius to diameter or diameter to radius. Feeling pretty good? Awesome. Yep, the big number is just 2. Radius times 2 equals diameter. Diameter divided by 2 equals radius. So now example 4 here at the bottom of page 3, we're going to be finding diameter and radius. And here, even though we're working with circles, we might not always be given the visual of a circle. That's all right. One thing you can do is you can draw your own visual. So here, we said that our circle has a circumference of 77.8 centimeters. So our C, iPad's acting weird. There we go. RC is 77.8. And we need to find the D, or the diameter, and the R, or the radius. Our formula from going between diameter and circumference is that the circumference equals pi times the diameter. So if we have the circumference and we need to solve for the diameter, that means we need to move pi to the other side. How would we move pi to the other side? Any ideas? We wouldn't subtract because pi and the diameter are multiplying together. Divide. Yep, remember, division undoes multiplication. So what we would do is we would divide both sides by pi. If we do that, the pi's on the right-hand side would cancel, and we see that the circumference divided by pi gives us the diameter. Well, this is great, because we know our circumference is 77.8 centimeters. We know pi is just a number, so we can use our calculators to figure out what 77.8 divided by pi is. So everyone grab your calculators and give that problem a shot. Who needs a calculator? I know there's some. Calculator. You're going to type in 77.8. You're going to hit the division symbol, and then you're going to hit the pi key. Does anyone need help finding the pi key on your calculator? Being able to use your calculator to solve these problems might be the hardest part of going between diameter, radius, and circumference. Good. Just like we were doing last module, it might require you to hit that little arrow button to get an answer in decimals. If we want to round our answer to the nearest hundredth, how many numbers do we include after the decimal place? 2. Yep. The hundredths place is the second place after the decimal. Are you able to get it? Perfect. Awesome. So reading off a calculator, you should have got 24.7645, whatever, keeps going on. Remember, the hundredth place is just that second number. The number after it is smaller than 5, so we round down. So we're just going to leave it as our final answer is the diameter equals 24.76 centimeters. We can write centimeters as just cm. The really nice thing now is that we found the diameter, and it is super easy to go between diameter and radius. Here, we still need to find the radius, but all we have to do is we need to use the number that we just found, this 24.76. This 24.76, all we have to do is divide by 2, and we'll get our radius. So if it's already in your calculator, you can literally just type in divide by 2, and it'll divide your previous answer by 2, and it'll give you the radius. So take a second and try to find the radius of this circle. If you need help with your calculator, just raise your hand. D divided by 2 equals R. Be able to get an answer. Awesome, great work. What was it again?
2.38.
Yep, and then just make sure you use your label. So just write it in centimeters. Make sure once you get that number answer, that bald answer, you stop it from being bald, you add your label, you make sure we're talking about centimeters. The answer you should have got is 12.38 centimeters. That's what we're going to leave off today. Miss Bryant just passed out the first homework for Module 5. Miss Bryant, what's the due date on that homework?
Can you go to the next slide?
Yep.
All right, this is due Tuesday.
You just have to do numbers 1 through 6. Can I borrow this? Numbers 1 through 6 is just the top half of the front side. That's all you got to do for homework. And it's due Tuesday, March 5th. So you got a while. That's all you got to work on for today's class.